Good evening. How's everybody doing? Let me fix this. Can y'all hear me? Hi, my name's Andrew Vaughn. I'm the VP of Engineering here at Project 44. Thank you for coming. I want to thank our friends at React Chicago for helping put this together and sponsoring this with us. I would be amiss if I didn't tell you a little bit about Project 44, what we're doing, and to tell you that we're hiring. We are one of the foremost logistics visibility companies in the world. We like to say that if you're getting a package on time, we'd like to help get it there. We process about 10,000 requests a second here. We do visibility insights for companies like Amazon, Walmart, Unilever in US and Europe. We do tremendous amounts of insights into truckload, ocean, freight, rail, air, and all the connections between them, helping companies understand where their supply chain is, helping them mitigate issues along the way if anything happens. And we've got a lot of fun things coming down the pipeline. If that sounds interesting to you, please reach out to one of our recruiters or come talk to me afterward, or any of our Project 44 staff. We'd be happy to talk your ear off about these types of things and give you more information about what we're doing. There's specific details about some of the roles we have on the placards here on the table. And sorry, I'm getting signals in the back. I'm not quite sure. But without further ado, I'd like to introduce Marques Woodson, one of our staff engineers at Nolte, who's a front-end engineer here, who's going to be talking about some of the new and upcoming technologies we have here, new for us, I would say, and why we made the decisions to switch over to some of those. So with that, introduce Adam and Marques.
Thanks, Andrew. Yeah, like Andrew said, I'm Adam Nolte, and this is Marques Woodson. We both front-end engineers here at Project 44. Thank you guys all for coming out to our talk titled Building Type-Safe Applications with React Hooks and TypeScript. We're going to kind of relate this to some of the decisions we've made and some of the technologies that we use here every day. So with that, this is kind of the agenda, what we're going to cover. First, I'm going to kind of talk about TypeScript, why we decided to adopt TypeScript, how we did that. And next, I'm going to kind of show some coding examples of how you might do this in your own application. After that, Marques is going to take over, and he's going to talk about hooks and how you might create your own custom hooks and use that with TypeScript as well to get that type safety in your app. We'll recap all of that, and then we ask that you hold your questions until the end, and we'll be around for a little while to answer those in chat. Real quickly, kind of like Andrew mentioned, what we do is, freight tracking. The product that Marques and I work on is called the Visibility Operations Center. So just to give you a little context when we're talking, this is what we're working on. And in the Visibility Operations Center, we'll sometimes also refer to it as the VOC, if you hear that throughout the talk. What we do here is you can see details on your shipment. There's maps, show you where that freight is, whether it's on a truck, ocean, ship, rail, and then we do some location management, some ETA type stuff, notifications, and then some collaboration around those items. So now to kind of go back to the start, these were some of the problems we were experiencing in our app as we were building it. We had a lot of large unknown data structures flowing through the app, which would cause bugs. When you're accessing something, you think it looks a little different. We've all worked on UI applications. You kind of know how this comes with JavaScript. Jumping into some of these changes, their changes were very difficult to make without prior domain knowledge. And a lot of the app had kind of been set up by a team of contractors who had plans to roll off. So we were planning on scaling the team up with full-time front-end developers, and we wanted people to be able to jump in, make changes quickly and confidently, and try to eliminate a lot of those little pesky bugs. So what we came up with is we decided we were going to try to adopt TypeScript into our application. We looked at a few other options. For example, we could have just gone with defining, all of our prop types, really enforcing that in JavaScript. The main issue with that was that wouldn't give us type safety, through utility functions, mapping functions, and those can be a little bit hard to enforce, to build correct and valid prop types just in plain JavaScript. Next, we looked at Flow, built by Facebook, so that you still, write JavaScript. You add Flow, which is a third-party library, and it's supported with React scripts, create React app as well. But we ultimately decided to go with TypeScript because of some familiarity on the team, and we'd used it before, and we could get up and running with it quickly. So if you're not familiar with TypeScript, TypeScript is just a superset of JavaScript. So you can write plain JavaScript inside of a TypeScript file, and you don't have to change anything. So, you can kind of, as you're learning it, you can start out by just writing JavaScript and start adding in some of the more advanced TypeScript features as you go and as you learn. And the other cool thing with TypeScript is if, say, you're running a Node backend, you can have your Node backend in TypeScript as well, and you can share some of those models between your front end and your back end. So if you change an API response or something, you also get that type checking. That model can be shared. And then later on, when as Marques will talk about, we added hooks into the equation. So our app is built with React, obviously, and Redux. And then, we started adding in hooks as well. So now I'm going to talk a little bit about how we went about this. So we had this, the VOC was written in mostly, or all JavaScript, had been worked on for probably 6 or 7 months. So it's a decent sized application at this point. So what we did is, if you're going to use TypeScript, if you're using Create React App, React Scripts, you have to be at least version 2.1 or higher. And that'll allow you to just use TypeScript out of the box. If you've ejected your React scripts, I'd say, take a look at maybe why you ejected and have your own custom Webpack config. They've likely added a lot of the features that you needed to React scripts. I think now they're on it's like version 3.3 or something. There is some breaking changes, so we were on like version 1, and to get at least above 2, there was some breaking changes. The good news is that React documents their releases really well. They kind of talk about how you can fix those breaking changes and get through that. Your next step is you install some TypeScript dependencies. This command is also on their website. And what you'll see if you're not familiar with TypeScript is some of these add types packages. So these are type declarations for JavaScript packages. So not all third-party libraries are shipped with TypeScript and type declarations. What you have to do is install these add types packages. A lot of them are definitely typed, and they've all been pretty good so far. We have not really run into any weird issues with any of our dependencies, not having type declarations or good type declarations. So if you have your existing app, after you've done all that, all you need to do is find a file in there, update it with a .tsx or a .ts extension. So change that from JS to TS or TSX, and your app will, once you restart your dev server, you're now running TypeScript. So the really cool thing here is, all you have to do is just do one file. JavaScript and TypeScript can work side by side. Your whole app's now going to be running through the TypeScript compiler, and it actually can do some inference on the JavaScript files. So when we just updated like our app.js to app.tsx, and a few errors popped up from the TypeScript compiler and a few of our JavaScript files just from it inferring like, here's a small little pesky bug you might have missed. So that was pretty cool. We gained some value out of that right away. And this was something that we were able to do really quickly. Really only took a day or two just to set this up, try it out in a branch, and start evaluating if this was something we wanted to do within our team. So if you're looking for a reason to try to use TypeScript, make a move to it, you can justify it by, it's not that hard, it's not going to take that long, I can just give it a shot. Another thing you could do is take a look at a few of your bugs in your backlog and say, oh, these would have been fixed if we had TypeScript, those small data access bugs. So now I'm going to kind of jump into an example app. I have a few videos of me coding and a couple of screenshots here of an app. So just to kind of set this up, this is just the to-do app with Redux. If you go to their website, you can clone their code sandbox. We cloned it. It's just a JavaScript app. You can add some to-dos, click on them to complete them. You can kind of see here some components, your Redux folder, your to-do app.js. This is all JavaScript. So what I'm going to demonstrate is how, if I'm looking at this and I say, all right, I want to convert this app to TypeScript, how might I go about that, okay? So first, I have open just the to app.js. There's a really obvious bug in the middle, but maybe if this bug wasn't so obvious, you'll see that TypeScript compiler is able to kind of catch these little bugs. So to start, I'm just going to go in. I've already installed the dependencies. I'm going to rename this to-do app to a .tsx file. So it's TypeScript. Restart my dev server here. And then once this compiles, you can already kind of see the red line right here. It's already found this error that JavaScript didn't catch. The app failed to compile because of this error right here where I'm accessing something that's potentially undefined and I didn't check for it. Once I clear all of that out and resave here, it's going to recompile and now my app's working. So it's just like that. My app's running through the TypeScript compiler. I got some checking, found a little bug. This is a very simple example, but if this was a much more complex component or utility function, I may not have been able to catch that as easily. Another thing I'm going to talk about, so that'll get generated when you're using TypeScript, is a TS config file. This is similar to like a JS config file if you're familiar with that. And the one thing, you don't really have to change much in here. The one thing I do want to call out is there's a setting in here called strict. And I would strongly advise that if you're just starting out with TypeScript in your app, that you keep strict to true. And that's going to really enforce you to use a lot of the strict features of TypeScript, like forcing you to define types, strict null checks, and a few other things. So I would suggest starting with that and then backing down if it doesn't work for your team. It's all about kind of finding that balance. So now I'm going to jump into a component and talk a little bit about how I might start using TypeScript inside an existing JavaScript component. So first, what I'm going to do is I'll come in here, and at the very top, you'll see, might be a little hard in the back, but at the top, I have export interface to do component props. So the naming convention that we've decided to follow is for our prop types, we always define those with TypeScript, and we define them with the name of the component followed by the word props. So that just denotes anywhere in our app that this type is the props for a component. And we use interface here. There's some good resources online about interface versus type in TypeScript. I suggest you go out, take a look at that. We made the decision as a team to use interface everywhere. That's just kind of our team practice. So then what I'm going to do, if I'm coming into this component here and say, somebody else built this with JavaScript, I'm coming in, I'm editing some features, and I want to convert this over to TypeScript. What I'm going to do is I'm going to take a look, and I can see that there's a to-do and toggle to-do passed into this as props. And then I can look at it, and I can say, okay, to-do has a property called completed, it has a property called content, and then it has a property called ID. So I can say, okay, I know this to-do at least has those three properties by looking at the component. So what I'm going to do is say, all right, this component takes in a to-do, and it has these three properties. It may have more, like I said, I'm just coming to this JavaScript file, I don't know. But I know it at least has three, so this is a good start. At least I'm starting to get some type safety here. And you'll see I use the keyword any on content and ID. And maybe I just don't know for sure what that's going to be, but at least I've defined that that's a property on there, and this is kind of a good starting point. Maybe down the road I'll discover what type content and ID is. And then you'll see I define the function toggle to do, and that takes in an ID and doesn't return anything. So at this point, I've defined the props for this, so when I go to use it somewhere else in a TypeScript file, I know what needs to be passed into it, and it needs to have at least an object with completed content and ID. And so now what I'm in is, this is a to-do list component. So it's going to use that to-do component, and I'm going to demonstrate. You can see here it has an array of to-dos with that same completed content and ID. And I'm going to demonstrate what happens when I use that to-do component now. So I'm using it from a TypeScript file. It's a TypeScript component. Whenever I remove that to-do, you'll see that I'm going to get a compiler. because to-do component requires a to-do. Right, so this is another kind of simple example, but say for example, to-do change shape, or it had this component took 5 or 6 different props. The app will fail to compile the minute you make that mistake. Whereas if you're just using JavaScript, you may not see this error until you're in your browser, you go to that route, and the app crashes. We've all been there when you got to wake up at night to fix one of those. So cool. At this point, we've used to-do list, we've used to-do component, and we noticed that there's some similarities between those. The to-do, they both take a to-do. That to-do has kind of the same shape, so maybe I want to create something to share between them. So what we tend to do is we'll create a models folder that lives with the features, and I'm going to define a to-do.ts, and that's an interface. And I'm going to define that completed content and ID. At this point, I figured out that content's a string and ID is a number. And so then, inside of to-do list and the to-do component, I can import to-do from that models folder and share that type between them. So now, say somewhere else, maybe where I'm fetching data or something, to-do changes a little bit, and maybe there's no longer a content. So I delete that out of this interface, and now my app's going to fail to compile because to-do component is accessing to-do.content. So you can catch those errors when your data model changes, your API contract changes, maybe you don't know everywhere this is accessed. The other thing I want to call out is you'll see as I was doing this, my whole app wasn't in TypeScript, only a few components. So that's kind of been our approach, is we only do new features in TypeScript, and then maybe if we are adding a feature to an existing part of the app that's in JavaScript, we may work to kind of start to convert that. But you don't have to go through and convert your whole app to TypeScript right away. You can keep delivering new features and just do your new features in TypeScript. I mean, we have some parts of our app that we haven't touched in months, and they're all in JavaScript and they work fine, and there's no reason for us to go back and update that. So this can definitely be an iterative thing that you do. I would say, so we started this project at the beginning of 2019. Our app is probably 50% TypeScript right now. So, a lot of our new features, you have to do it in TypeScript, and you have to define the data models on a PR. If you submit a PR and in TypeScript and you are using anywhere and you're not defining your types, we'll reject that and try to figure out what the data model is. But if you're updating an older piece of the app, we kind of say, give it your best effort, try to define types on what you can, and everywhere else use any. So with that, I'm going to hand it off to Marques, and he's going to kind of talk a little bit about hooks and how you can use hooks and TypeScript together to kind of. So yeah.
Thank you. Hello, everybody. I'm going to talk to you guys about React Hooks. So you might be thinking, why should we even think about using React Hooks? React Hooks have been introduced by the React team back around version 16.8, September of 2018. And they were created to give your functional components a way to handle state and a way to handle lifecycle methods. If you know anything about React before, you had to write a class. Those always came with different lifecycle methods: component did mount, will mount, unmount, all that stuff. And there was always a way to handle state. Well, eventually people who either didn't come from an object-oriented background and didn't really understand how classes worked, didn't want to take that hurdle and jumping into that just to create a component. So React introduced functional components, which were just functions that return HTML. The initial problem was you don't have state, so you're going to have to move that somewhere. Redux was a common choice, but that's what you were kind of left with. Something else that was a problem with different classes or using classes are major browsers still don't know what classes are. They don't have the concept of JavaScript classes. So what happens is when you have Babel or your TypeScript or Parcel or something, those classes get turned into just functions, function prototypes, and they become big blocks of code. This does add to your footprint, Depending on how big your app is, that might matter to you. If it's very small, it might not make a big deal. If it's very large, that kind of thing does matter. Something else we saw when we were using hooks was we just naturally found it easier to keep some of the functionality alongside the features or the components that we're building. We would have a hook related to one specific component, even though we can use that same hook anywhere, but we would keep it alongside. And when we would do something like Redux, we would have to make sure we followed what was actually in the application there. The different conventions there were a little bit different. You know, your state kind of goes and lives in the store somewhere, and you have actions and things like that. And when we were looking at our application, we knew it just wasn't going to be really easy for new engineers to come on. It wasn't easy to understand where everything was actually happening and how to change things. So the one thing to know about hooks is they only work inside of a functional component. They are, like I said before, they're not meant for classes. Classes already have lifecycle and state. So if you're trying to import a hook and use it in the class, you'll probably get an error. I mentioned some of these things earlier. If you are using something like utility functions and helpers, sometimes if you have the scenario where when something changes, and that something could be any type of state, and you want your React component to re-render, you are probably going to want to use a hook. And I'm going to show you how that works in a few minutes when we go through some code. So how do we actually get hooks into our app? Like I said earlier, you're going to need to upgrade your application to use at least version 16.8. That's when the hooks are introduced. Anything before that just won't really work. If you're already using Redux, you don't have to feel like you have to move any kind of Redux or MobX or whatever outside of your application. Redux even has Redux hooks. If you use Redux that you can use if you wanted to. When we're going to be comparing Redux and hooks, but it doesn't mean we're trying to add Redux. Like we still use Redux every day. But if we're creating something new, we're going to be using hooks. So if I have a new feature, my first step is probably not going to be creating a new store, creating a new set of action creators, and dispatching, connecting a component. It's probably going to be create a custom hook that will do that kind of data manipulation, do that kind of work instead of using it inside of Redux. There are some pretty strong cases for you sticking with your state being in Redux. For us, it's more like user authorization. So if I log into an application, that user is going to have access to different parts of the app. They're going to have different tenant flags, different feature flags associated with them. That kind of information that would probably be used in any component or all over the application, where like that can just stay up and stay in Redux. You don't need to make a whole new hook. Not saying you can't do that, but if you're already using Redux, that's a pretty solid way to know what should stay and what would be safe to kind of move out of that situation. One of the first hooks we made, it was a custom hook. It was for our landing page. We had to build this new map. And basically, when you log in, you see this map that has a bunch of markers all over the place. Shows the entire world. It basically shows a bunch of shipments that are out in the world right now. The whole point of our VLC is I want to know where my stuff is, and we built that stuff. So we made a use landing page map hook, which basically takes the fetching of the data, fetching of the different shipments out of a Redux store or out of the, we have what we call an operations file, and we put it into a hook using a use effect hook. We put into a custom hook that uses the built-in use effect hook. I'll explain more about the built-in hooks versus custom in a little bit. So we were able to put all of this logic into one hook. It wasn't a ton of stuff. It was basically fetch this data and return it so I can actually use it inside of a React component and display it on the map. And make sure the map updates whenever new shipments come in. We were able to reduce a lot of extra code, have around 200 lines here, and just kind of makes the code feel like you're more just sticking with the React interface instead of trying to do it with a third-party library. So I'm going to pull up a code sandbox. Can you guys see this okay? Some of the font size need to be bigger. Okay. We are looking at our custom use to do's hook. So basically this application was already a Redux-based application. Like he said, we pulled it from Redux, that's where it was sitting. So what I wanted to do was try to see if I can pull some of that functionality of adding a to-do listing to-dos and toggling what you can see and kind of storing that into a hook instead, but you know, keep the exact same functionality. And also make sure it's all type safe with TypeScript. So here on line 22, we are just defining the use to do's hook. Quick side note, when your naming convention for hooks, they should be use and then something. So use to do's, use landing page, use some, whatever. That is not a strict convention. If you want, you can name it whatever you want. But the thing you're going to lose out on is any of the linting you have. I guess you're going to be using some type of React ESLint parser. And the reason they tell you to make sure you call it use something is so that that will know what is actually in hook and how to tell you to not do stuff. Because there are a few rules that you have to kind of live by when you're creating a hook. All right, so here, if you're not familiar with TypeScript in the return type of a function, that's kind of what you're seeing. You have this colon and I'm returning an array. This is basically just saying use to do's is going to return an array with these things in it. I'm returning an array with a to-dos state. This is going to be our state property, which is actually our to-dos. The type is to-dos there. I have 3 functions that right after that where I'm adding a to-do, I'm toggling that to-do, and I'm toggling the visibility of that to-do, which is handled by these all complete or incomplete. So we're going to talk about this destructuring and why we're actually returning an array when we talk about this use state hook. So the built-in hooks that you're going to see here are these React.useState. Those are right on the React object, and this is pretty much how you would use them. So use state is how you give your functional component state. It's basically saying, if I'm reading this code, I want to-dos, this variable to-dos to hold the state of this component or whatever the component is going to be using this hook. This set to-dos function I have right after is your state updater. You could think of it as set state in a class. It's pretty much the same thing. Every use state call is going to return that. Use state always returns an array. We destructure it here just to make it a little easier to read. You could just make that one variable, but every time you called or your state or your updater, you're going to have to pass in the index 0 or 1. I think it's kind of annoying. So we are defining the to-do state variable here. I'm defaulting the value to just an empty object. In this bracket to-dos here is I'm just telling it the shape of to-dos. To-dos needs to follow this shape. That's a TypeScript thing. We're doing the same thing with the filter here. I'm just saying it's going to be the visibility filters. It is going to hold what filter we are at right now, and I'm going to default it to all. So you can see we're still underlined all there. As I change, as I click on one of those filters, set filter is going to be called with the filter value that I want it to be, and it'll be updating filter, and at the same time re-rendering the component. This filter to-dos variable here is the list of to-dos based on the. See on the side. Sorry about that. The filter to-dos object I have here is just the list of to-dos that's going to be based on the filter. I have a get to-dos by visibility filter function that is just a helper function that's going to return. It filters through all my to-dos, finds the ones that I need. So now we're going to see how do we actually update the state using a hook. So in your mind, you're thinking, this is basically how do we set state in our component. I have two quick functions here. We have add to do, we have toggle to do. They're doing pretty much the same thing. Add to do is just going to take the content, which is whatever you type in the input field there. I'm going to create an ID variable based off of this next to do ID that just increments every time a new to do gets added. It starts at 0, just keeps going up. And then I call set to do's. So set to do's, again, it's that updater function that I defined when I created the state variable to do's with use state. And the value that I'm passing in, it follows the to do's shape. So I'm just spreading in what current to do's you have there. I'm adding one more with that new ID. They're all going to be keyed off the ID and the content of that to do. Toggle to do is doing pretty much the same thing, except I'm passing in the ID and I'm updating the completed property based on whatever it was before. It just flips it. At the bottom here on line 56, we are returning that array of those 5 items that I had up in the return type for this hook. There's those filter to-dos, my 3 functions, and what that actual filter, what the filter is in this state. So how do I use this to do? This use to do hook. If I look at the main component for the to-do app, here's where we can import this hook. We can call it, get all of those values. I made sure it looks very similar to the use set state. Just makes it a little bit more familiar. And I can pass those functions and the list of to-dos down to the components, the 3 components we have there. Add to do is just that input field in the button. To-do list is it says no to-dos yay right now. It's because this right now is still an empty object. And the visibility filters are the 3 filters at the bottom. So I can pass those down into it. So right now, the only part of this application that knows about the use to do hook is going to be this component right here. The other ones are still just taking in props. Very similar to when you connect a component in Redux and you're using map state to props. That's pretty common function name we use when we use Redux. It passes all your dispatch functions and your state as a property. Kind of the same idea here. If we look at the add to component, we can still see our add to function here. We can see the type safety is telling us that it just takes a value, which is a string, and doesn't return anything. I call it when I click on add to do, only if you type something into the input field. And that's really it when you're trying to use a custom hook in React. There's not a ton you have to do. We were able to disconnect, just remove the Redux connect from all of these components, and we're handling that state in the use to do hook there. All right, so why should we even think about adding these new technologies or adding these new patterns? Like Adam was saying, some of the problems we were running into was just trying to get up to speed in that current code base. Since we didn't build the code, we didn't build the application, so you come in and you kind of just are reading through the code, you're playing with the app, you're just trying to figure things out. We saw that once we had types on our components, once we had types in our different hooks, once we had types all over the app, we were able to skip over introducing bugs into the app, figuring it out when we see it, the string not working, and then go back and fix it. Catching everything at compile time was something that made us move a little bit faster. We were able to not introduce as many bugs. I don't have a number of the bug reduction, but I'll make one up. It was probably 90% and growing. So we were able to hire new people, have them come in and contribute to the application a lot faster when we weren't able to just kind of, when we didn't know what was actually happening in the application. Like Adam was saying, there are different areas in the app where it's a lot of code, a lot of untyped code, and we're a little scared to touch it because it's working today, and we go, maybe we should add types to this, and I change one thing, and everything fails. I'm like, nah, we'll just leave that, and it needs to change in a year. We'll think about it and switch over to a new framework or something. But I still say, if you have a chance to if you want a chance to try to improve the application, adding these types are just going to make everything better, I feel like. We have a nice quote that Adam loves. I really wanted to say.
Yeah, we had this quote at the end. It said, "I love the new technology. New things give you a reason to want to go to the studio. New challenges mean you have to keep up." You know, this is by Dr. Dre. When you're using new things like TypeScript and hooks and staying up to date with the industry, you know, it challenges you, keeps you excited to come into work and work on new things and challenge yourself. So with that, we'll turn it over to questions. Yeah. Yeah, so the question is, how do we, just kind of summarize, like how do we use TypeScript with Jest, and if we're testing new functions, TypeScript? Oh, if you were going to extend add types Jest? Yeah, you know, we have not had to do that yet, so I'm not sure. I haven't had to look into that. The use case hasn't come up for us yet where we've had to extend a type declaration file that we imported from a third party.
But so we showed you interfaces, and we kind of just mentioned about types and interfaces and what the differences are. So one of the main differences are going to be, so Jest will have its own type declarations. And if it's an interface, you can create a new interface that implements another interface. You can't do that with type. But so that will be a way of you saying, I want this to have these new properties, but also these. It's similar to if you're working with classes or something. If you're using types, it will be more of there's a thing called union types in TypeScript. So you could have my new type equals, you know, this Jest type and a bunch of other stuff that you want. So it wouldn't be specific to Jest or anything else. It's more just a way of handling and extending and implementing types. It's more of a TypeScript pattern. So that would work with whatever interface or type or class that you wanted to use. That answers your question. Any more questions?
So one thing that Adam brought up earlier in this discussion was that the advantage of TypeScript is that you could export these interfaces and say like syntactic services, spit out interface that's shaped like this, and then you have some other services. How exactly would that be handled? Import these. What happens when you change your?
Yeah, pretty much. So just like you saw when you install TypeScript the first time with Create React App, you're installing those @type/whatever. You could pretty much make your type declarations its own module that gets imported from whatever wants to consume it, so your client side and your server side. The handle changes, similar to a lot of different dependencies. If you update your dependencies, you're gonna have to make sure the dependencies are in sync. If you're doing that kind of application, it might be easier. Well, I won't say easier. One way to do that would be if you have something like a monorepo or Tradeoffs Learner. It's like a tool that you use to manage a monorepo. Keeps your dependencies in sync. I would recommend going that route if you were going to have something like a backend, a front end, and a type as 3 separate modules. Or when I say modules, like 3 separate applications, really. but you need them to be all be in sync together. If you weren't going to use something like Learner, because there will be a learning curve to kind of get into that, yeah, it would just be a little harder. But you can still do it if you try. Yeah. It'll.
Yeah, so the question was, what would happen in that custom hook if you messed up the order that you were importing those? So the cool thing is when we're typing that hook, each item in that array is typed, so we know that the first item in that use to-dos hook is going to be to-dos. We know that the second item in that array is going to be that function. So when that gets returned, wherever we're using that, as long as we have our types for our prompts and things like that, that type safety will go through all of that. So if we flip something, the app's going to fail to compile because if we name the function, maybe we name that as to-dos. When we pass that down into the to-do component, we have the to-do component expects a to-do of a certain type, and when it gets a function, TypeScript's going to fail to compile. And so that's the kind of cool thing with the hooks versus Redux. Redux, you can do some types and things like that, but you have to use type-safe actions and some third-party libraries, and you can kind of get a lot of boilerplate. But with the hooks, you can, as long as you're typing that return type, everything you return out of there will have to be type-safe as well.
What strategies are you guys using to test space components?
Yeah, so the question is, what strategies are we using to test hook-based components? Do you want to talk about React testing library?
You can go first.
Yeah, so we use a library called React Testing Library. So a lot of our hooks, they can be a little challenging to hook test with Jest. So we use React Testing Library, which just renders the component and we're just testing the DOM, the output, like as a user would see. So usually what we'll do is test that through a component that we're already testing with React Testing Library.
I'll just add. So when we're writing these tests, we aren't completely trying to test, what is happening with this hook. The idea is more about testing because a user using the application doesn't know what the hook's happening. That's not something they're thinking about. It's more like, if I click this button, is this notification going to show? And making sure that works. And it would fail if your hooks are failing. So yeah, we're not specifically trying to test does the React hook work. I guess we can kind of trust that the hooks that are coming from React are working.
I have a question about
the question was why TypeScript over Flow, and if we had any more comments about that. I know back when Flow first came out, I was trying it out for a little while and didn't have the greatest experience. That might have biased me for future projects of trying to use it. TypeScript was gaining a lot of popularity. Yeah, I think for me, at least, it was just kind of when I was using TypeScript on a new project, it would just kind of work. Flow was having memory issues and it wasn't the greatest experience. I know there's a benefit to Flow over TypeScript. I think it was its inference was better or something like that. So you could turn Flow on and your functions, TypeScript might just say this is any, where Flow would kind of tell you that this is actually a function or a string or a number or whatever. But we both knew TypeScript, and we brought another engineer. They knew TypeScript, and it was just kind of like that's what we're gonna sit there. So the question is, how do we handle types between the front end and the back end? API changes, front end breaks. So when I was talking about that Learn stuff, that's a solution. That's not what we do right now here. One solution that you could do that we've been talking about a little bit is we use Swagger for our documentation of our APIs. There are tools for basically exporting types based on their Swagger documentation, and they can be exported into TypeScript or a bunch of different languages. I would say I would look into something like that. I forget the name. It's like Swagger Open Docs or something. But you can go to your Swagger documentation, export those types, and pull those into your application. Now, that would mean you have to do that every time your API changes. Every time it builds, I would say, is export those somewhere where you can pull them in. An external JavaScript, a node dependency would probably be a good way to do that. You need to make your own NPM project that held those types. You can do all that in your build pipeline. But that'd be one way of doing it. The other one is sitting with your backend guys and talking, I guess. But the better way would be exporting that documentation. The mono repo. That was one way I've seen it done, where you keep your backend, your front end, and a third dependency, which is just your types. So both of them can use them. That only really works. It works best if the backend and front end are both written in the same language, JavaScript. But if you have like a Java backend and a React front end, then you still need to kind of export those types because the files aren't going to work the same. What's happening? Oh.
Hello.
Hello. Any other questions? Right. Yeah. The question is, are there any Redux dev tools which are great for hooks?
You do lose some of that debugging and undo functionality, like with the Redux dev tools. So there is a little bit of trade-off with that if you're used to seeing all those like your asynchronous calls and all that flowing through Redux. But my argument back to that would be you gain some simplicity in your code and less boilerplate of when you're looking through the code base, going through an action file, an operations file, and a reducer. If you can just take a look at that one hook and see where it's fetching the data and storing it all within that same hook. So there is some trade-offs and some benefits when you decide to do that. Any other questions? One more? Yeah. With the context API? Yeah. Yeah, so the question was, have you used hooks with the context API? And yes, we do. So we've taken a look at using the, kind of like how Marques was mentioning, you could keep your user authorizations in Redux. Another option is you could keep that in the context API. React's context API allows you to access like state from anywhere in your app, and they actually have a use context hook as well. And you can type the context hook as well, so that can be another option if maybe you're starting a new project and you maybe don't even bring in Redux right away until you need it. Yeah. All right. Yeah. The question was, have we found any challenges to storing data in context as opposed to Redux? We haven't really used the context API enough to probably really comment on a lot of the big differences. A few of the simple things that we've done, we found it to be easier adding types to the context and the built-in types that you can get with React. as far as, yeah, we haven't really probably used it enough to have a good opinion on some of the challenges between them.
Yeah, like he was saying, there's a bit of simplicity that comes when you're using the context API and hooks. And like normally, if I'm going to create a some type of context and store data there, I've still used their. So we didn't really talk about all of the built-in React hooks. There's like 8 of them or something, and we didn't have time. But there's one called use reducer, and the idea there was you can look at your Redux reducer, which is just a function that has a switch statement, takes in state, takes in an action, and a payload, and it just returns the state. Same exact idea. So if I'm creating a new context provider, I am probably going to make a use reducer, and I'm going to have those same state actions in there, and the same state, same way to dispatch. And even you can still use the word dispatch when you want to use it. I would normally create a hook that all that hook does is return the state in dispatch. That way, everywhere in my app, if I want to use that context, it would just be like, use login or authorization context. And then I have my state, and I have a way to dispatch some type of action. So for problems, I personally haven't seen any new problems that I didn't see in Redux, or vice versa. I think they work pretty well together.
Have you seen an increase in your reload times?
The question was, have we seen an increase in reload time with TypeScript and compared to JavaScript? So do you mean like page reload?
Yes. You're a dev server.
Oh, in dev server? So when running, yes, there is increased time in compiling your TypeScript code. So what Webpack has done and working with the React team is they've split up. And if you ever put together a Webpack with TypeScript on your own, you might have run into this where you can split up your type checking and your compiling. So you can have your types run at the same time in parallel while your code is actually turning from TypeScript to JavaScript. So that is going to be faster than before when it had to work in synchronously. But there will be an increase, but it hasn't been anything that we've noticed to where we're just like, annoyed or anything like that. And also, it'll depend on how large your application is. If you have an application with 1 million lines of code, then there will probably be much longer wait than if you didn't. So yeah. Well, thank you for coming and listening. Thanks for all your great questions.